Welcome students. Today we will discuss about classical encryption techniques. So in previous lecture we discussed about the introduction to cryptography. In that we discussed some of the basic terminologies that are used in cryptography. And in cryptography we discussed about the type of ciphers, in which we discussed about one is the substitution cipher, second are transposition ciphers, and the third is product ciphers. So these are the different encryption methods. So from those encryption methods, we are discussing one of the encryption method that is called as the substitution method, and the ciphers that make use of substitution methods are called as substitution ciphers, or we call it as the classical substitution ciphers. So in classical substitution ciphers, letters of the plain text are get replaced by other letters or by other symbols. For example, if we have this thing, we have A, B, and C. For example, this is my plain text. Consider this as plain text. So it will get replaced by, for example, A will get replaced by D, B will get replaced by E, and C will get replaced by F. That is the 3 letters down, right? 3 letters down in our alphabets. 3 letters down. So this is the one thing, right? Okay. This is called as the substitution, right? This is called as the substitution. Substitution, right? We are substituting a character or replacing a character or a symbol by another one, or replacing a letter by another letter. So the very first substitution cipher that is developed by Julius Caesar, and that is named after his name, that is called as the Caesar cipher, in which this is a very basic substitution cipher. For example, you can see here, this is my plain text. Okay, this is my plain text, and my key is 3 letters down. Replaces each. This is my key here, right? Okay, this is the key here. That is, we have to replace each letter by 3 letter down. Okay, right, 3 letter down, or we can say this is my method. So when I'm talking about this particular 3 letter down, so you can see here this MEET, meet me after. So A will get replaced by D here, right? Okay, right. A will get replaced by D here, right? So this is, in this way this encryption has taken place, and this is a kind of a substitution method. So further, we can define mathematically also, that how we can define this one. So this is our mapping here, right? We can say this is the transformation or a mapping. A will get mapped to D, B will get mapped to E, C will get mapped to F, and so on, and Z will get mapped to C, right? So these are the 26 alphabets in our English, and we are making a mapping of this particular by making them the 3 letters down. So mathematically, we can also give each letter a number starting from 0 to 25. We can give it a number, and this is quite, it makes our process simpler when we are performing encryption on our plain text. Okay, and we can write it mathematically also. Now, encryption here is P plus K mod 26. Okay, encryption is P plus K mod 26, and decryption is my P is basically my plain text, K is my 3 letters down. So if I'm doing something like, for example, if I'm doing about A, right? So A is represented by a numerical value of 0. So it will give me 0 plus, this is 3 letters down. So K, value of K is 3, and mod 26. So 3 mod 26 gives me 3, and add 3, if I see here, add 3, the letter is D. So A will be substituted or replaced by D, right? A will be replaced by D. right? So in the similar way, if my ciphertext is D and D is replaced by D is having a value of 3, so my formula now becomes C minus K. So this is 3 minus 3 mod 26. So this gives me 0, right? And 0 is represented by A. So this is the way we are doing encryption and decryption, right? In case of the very simplest substitution cipher, that's called as the Caesar cipher. Okay, right. So quite simple, but this is the way, very first algorithm, right, that we are discussing, right? Very simple algorithm, right? Okay, this is my plain text P. This is K is nothing but a 3 letters down key mod 26. When I am deciphering it, or when I am retrieving or recovering a plain text from the ciphertext, what should I do? I will do C minus K mod 26, right? So it is saying that what about the cryptanalysis? So you know that the cryptanalysis is a technique of decoding messages from a non-readable format back to a readable format. So we have only 26 possible ciphers, 1 letter down, 2 letter down, 3 letter down, and so on. We can make the 26 combination in such a way, and we can for cryptanalysis of this particular cipher, we can just simply try each in turn, and this is from that particular a kind of a brute force search. We will try each in turn, and for a given ciphertext, we just try the shift of letters, right? Okay, right. We try the shift of letters. Then we have two different types in which ciphers are further divided. One are basically called substitution ciphers are divided, right? Okay, substitution ciphers are categorized as substitution ciphers are categorized into the two different categories. One are called as monoalphabetic ciphers, and second is called as polyalphabetic. Okay, polyalphabetic ciphers. Mono means single, right? Mono means single replacement. Single replacement. Replacement. And poly means many. Poly means many. Right? That is the difference between mono and poly. Okay. So in case of monoalphabetic cipher, we can just shift the alphabet, right? Or jumble the letters arbitrarily. Now each plain text letter maps to a different random ciphertext letter, and the key is 26 letters long, right? For example, this is a plain text, and we are jumbling them arbitrarily, right? Okay, so when we are jumbling them arbitrarily, the number of possible combinations, if the letters are 26, so number of possible combinations are 26 factorial, right? Okay, so for example, if my key consists of, in a smaller scenario, we can see if my key consists of only the 3 letters, the number of possible combinations are 3 factorial, that is equal to 6. Right, we can build the three combinations like A, B, C. We can build A, C, B, right? We can build a combination as C, A, B. We can build a combination as B, A, C. We can build a combination as B, C, A. And at last, I can build a combination as C, B, A, right? So you can see here, this is 1, 2, 3, 4, 6. Right, the number of combinations are 6 combinations. Then the similar letter, if my key is of 26 letters, the number of combinations will become as 26 factorial, right? So quite difficult to apply a brute force attack. In this particular case, it is quite difficult to apply a brute force attack as compared to our Caesar cipher. Caesar cipher. Okay, right. So during cryptanalysis, cryptanalysts are the persons who perform cryptanalysis. There are the terms that are related with that are helpful for them. For example, language redundancy, that includes the frequency of letters that occur commonly. Okay, right. For example, from this particular graph, you can see here the frequency of occurring of E, the spike of E is quite high, right? Okay, this is a spike of E, right? So that is relative frequencies as compared to the other letters for E, I, E, T, I, right, A are quite high as compared to O, right, as compared to the other ones. And you can also visualize here the use of Z, right, and X and Q are quite less, quite less. Okay, so from these particular frequencies, cryptanalyst can make a guess about a particular combination of the letters or key, and he can decode your message, right? So this is the same thing that's written here, right? We have a peaks at A, E, and I, right? NO and RSD, and we do not have high peaks on X and Z, right? So next is polyalphabetic ciphers. So polyalphabetic means many, right? They, they improve security by making use of multiple cipher alphabets, right? And it makes cryptanalysis harder with more alphabets to guess. And it uses a key to select which alphabet is used for each letter of the message, right? So thank you very much.